Welcome, network administrators and security architects. I am your expert technical instructor. Today, we are exploring a highly critical domain of the GH-300 certification, configuring IP allowance lists and firewall settings for GitHub Copilot network traffic. Let's secure our AI perimeter. Welcome, network administrators and security architects. Today, we are exploring a highly critical domain of the GH-300 certification, configuring IP allowance lists and firewall settings for GitHub Copilot network traffic. As enterprise adoption of generative AI accelerates, securing the network perimeter is paramount. GitHub Copilot requires communication with cloud-based large language models and various APIs to function. Without proper network guardrails, organizations face significant data exfiltration risks, where malicious instructions could potentially leak proprietary source code to unauthorized remote servers. To combat this, GitHub Copilot utilizes an integrated firewall that actively limits outbound internet access from its ephemeral environments. Furthermore, at the corporate network level, administrators must explicitly define routing rules to strictly govern which tiers of the Copilot service, such as business or enterprise, are permitted to communicate through the corporate proxy. Throughout this advanced module, we will deep dive into configuring subscription-based network routing, managing the integrated cloud agent firewall, establishing custom domain allow lists for private package registries, and handling complex proxy setups. Mastering these network configurations ensures that your AI-assisted development remains completely secure, compliant with zero trust principles, and perfectly aligned with your enterprise's overarching data governance strategy. Let us begin by examining subscription-based routing. When configuring Copilot within secure environments, you often need to route traffic through a corporate proxy. This requires setting environment variables like HTTPS_proxy, HTTP_proxy, and NO_proxy. The NO_proxy variable takes a comma-separated list of hosts or IP addresses that should bypass the proxy entirely. Properly defining these ensures Copilot's telemetry and prompt payloads securely traverse your internal network boundaries without disruption. This initial flowchart illustrates the high-level architecture of Copilot network security. Developer prompts originate in the IDE, pass through the corporate network firewall, which enforces subscription routing, and then interact with the GitHub Copilot API. Simultaneously, the cloud agent environment uses an integrated firewall to strictly limit its outbound internet access, preventing unauthorized data exfiltration. Moving to our first major technical configuration, the GH-300 exam tests your ability to implement Copilot subscription-based network routing. As an enterprise or organization owner, you must use your corporate network firewall to explicitly allow or block access to specific GitHub Copilot plans. This is a critical security measure to prevent developers from bypassing corporate policies by using their personal Copilot free or pro accounts on company devices. To enforce this, you configure your corporate firewall to intercept and route traffic based on specific, fully qualified domain names. If your organization uses GitHub Copilot Business, you must explicitly add api.business.githubcopilot.com to your firewall's allow list. For Copilot Enterprise, you add api.enterprise.githubcopilot.com. Because Copilot relies on multiple subdomains to function correctly, you must use wildcard characters in your firewall rules, such as .business.githubcopilot.com. Crucially, to enforce strict corporate governance, you must simultaneously update your firewall block list to explicitly deny traffic to .individual.githubcopilot.com. By actively filtering these endpoints, you guarantee that all AI-assisted coding activity on your network is governed by your enterprise's strict data privacy agreements and telemetry policies. The firewall rules displayed here demonstrate the exact configuration required to enforce subscription routing. By allowing the business and enterprise wildcard subdomains, you enable authorized Copilot traffic. Conversely, explicitly blocking the individual subdomain prevents users from connecting their personal Copilot licenses. This ensures that all prompts and code snippets remain protected under your enterprise's intellectual property indemnification terms. This sequence diagram visually maps the subscription-based routing logic. When a developer attempts to authenticate, the network firewall inspects the destination URL. Traffic destined for the approved business or enterprise subdomains is successfully routed to the respective Copilot backend. However, if a developer attempts to connect via an individual endpoint, the corporate firewall immediately drops the connection. Beyond the corporate perimeter, we must secure the ephemeral environments where the GitHub Copilot Cloud Agent executes tasks. By default, the cloud agent's access to the public internet is limited by an integrated firewall. This is designed to mitigate the severe risk of malicious prompt injections or hallucinated commands exfiltrating your proprietary source code to an attacker-controlled remote server. However, to build and test code successfully, the agent still needs to download legitimate dependencies. To solve this, GitHub provides a recommended allow list that is enabled by default. This recommended list permits outbound traffic to OS package repositories like Debian and Ubuntu, common container registries like Docker Hub and Azure Container Registry, and package registries for popular programming languages such as NPM for JavaScript or PyPI for Python. It also allows traffic to common certificate authorities to validate SSL certificates. Organization owners have the supreme authority to configure these firewall settings at the organization level, locking down the options for subordinate repositories. Repository administrators can also manage these settings if the organization owner delegates the authority, toggling the recommended allow list on or off depending on the specific security posture required for that codebase. This JSON snippet represents the backend configuration state for the Cloud Agent firewall. In a highly secure enterprise, you will typically see the firewall status set to enabled, and the use _recommended_allow list set to true to allow standard package resolution. Crucially, the locked _ organization flag indicates that an enterprise administrator has strictly enforced this baseline, preventing repository-level administrators from dangerously disabling the firewall and exposing the environment. The flowchart on screen details the Cloud Agent's outbound traffic evaluation process. When the agent attempts to resolve a dependency, the request hits the integrated firewall. The firewall checks the destination against the recommended allow list. If the URL matches a trusted package registry like NPM, the traffic is permitted. If the destination is unknown or suspicious, the firewall decisively blocks the outbound connection. While the recommended allow list covers public registries, enterprise development heavily relies on proprietary internal package managers. To accommodate this, administrators must create custom allow lists. A custom allow list defines the exact domains and URLs that the Copilot Cloud Agent is permitted to access. When configuring these rules, you must understand the distinction between domain and URL targeting. If you create a domain rule, such as packages.contoso.corp, the firewall will seamlessly allow traffic to that exact domain and all of its subdomains, like prod.packages.contoso.corp. However, it will not allow traffic to a sibling domain like artifacts.contoso.corp. Alternatively, you can create highly restrictive URL rules. A URL rule, like https://packages.contoso.corp/project-1/, dictates that traffic is exclusively allowed on the specified HTTPS scheme and host, and is strictly limited to the specified path and its descendant paths. It allows access to project1/tag/latest, but it will actively block attempts to reach project 2 or unencrypted FTP protocols. By carefully layering these domain and URL rules within your repository or organization settings, you guarantee that the AI agent can autonomously resolve your private enterprise dependencies without opening arbitrary backdoors to your internal network infrastructure. Here we see the structural difference between custom domain and URL rules. The domain rule for packages.contoso.corp is broad, granting Copilot access to the entire domain hierarchy for package retrieval. The URL rule is significantly more granular, restricting access to a specific HTTPS path on the artifact server. If Copilot attempts to download a payload using standard HTTP instead of HTTPS on that URL path, the integrated firewall will instantly reject the network request. This diagram highlights the custom allow list routing logic. A dependency request is generated by the AI agent and inspected by the firewall. It evaluates the request against the custom rules array. If the request matches the allowed URL path and the secure HTTPS protocol, the download is authorized. Any deviation from the explicitly defined scheme, host, or path results in an immediate connection termination. A highly advanced networking scenario tested on the GH-300 exam involves operating the Copilot Cloud Agent on self-hosted GitHub Actions runners. Organizations often deploy self-hosted runners using the Actions Runner Controller, or ARC, to provide Copilot with direct, secure access to internal backend resources that are isolated from the public internet. However, there is a massive architectural caveat you must memorize. The Copilot Cloud Agent's integrated firewall is fundamentally incompatible with self-hosted runners. If you attempt to run the agent on a self-hosted runner with the integrated firewall enabled, the agent's operations will be completely blocked. Therefore, you must explicitly disable the integrated firewall in your repository settings. Once disabled, the responsibility for preventing data exfiltration shifts entirely to your corporate network security team. You must configure your Azure or local network firewalls to securely allow connections to the standard hosts required for GitHub Actions, as well as specific Copilot API endpoints, like api.enterprise.githubcopilot.com. Furthermore, you must define the target environment within your repository by specifying the ARC scale set name in the runs-on parameter of your Copilot setup steps.yml workflow file, ensuring the agent initializes in the correct secure zone. This YAML snippet is critical for configuring self-hosted executions. The Copilot setup steps.yml file dictates where the agent's ephemeral environment is built. By changing the runs on attribute from standard Ubuntu to your custom Arc Enterprise Secure Runners label, you command GitHub to spin up the agent on your internal infrastructure. Remember, to make this work, the integrated repository firewall must be turned off, and your physical network firewall must take over the traffic filtering duties. The diagram on screen maps the self-hosted runner execution flow. Because the integrated firewall is incompatible and disabled, the Copilot Cloud Agent boots directly onto your Arc scale set. From there, all outbound traffic flows directly into your corporate network firewall. The corporate firewall now bears the sole responsibility for validating domain allow lists and blocking unauthorized data exfiltration attempts. In our final slide, we address configuring complex proxy environments and custom certificates for the GH-300 exam. When your enterprise network intercepts SSL connections for deep packet inspection, Copilot tools will throw network errors unless configured. You must set the SSL_cert_file or node_extra_ca_certs environment variables on your developers' machines to point directly to the SSL certificate presented by your proxy server. This establishes a chain of trust and prevents connection rejection. Additionally, if your corporate proxy utilizes Kerberos authentication, you must explicitly override the default service principal name. In Visual Studio Code, you add the http.proxy Kerberos service principal property, mapping it to your specific proxy service. For JetBrains IDEs, this is managed within the Network tab under the GitHub Copilot Tools menu. Mastering these nuanced proxy settings, alongside the rigid implementation of IP allowance lists, subscription-based network routing, and custom firewall allow lists, guarantees that your enterprise can safely scale AI development. You have now completed this comprehensive network security module. To guarantee your success on the official GH-300 exam and elevate your architectural expertise, visit quicktechie.com for full courses and advanced practice labs. This JSON configuration is required when running Copilot behind a strict corporate proxy. The HTTP proxy setting defines the explicit routing path and port, optionally including authentication credentials. Crucially, the HTTP proxy Kerberos service principal overrides the default SPN to align perfectly with your enterprise's Active Directory integration. If these parameters are misconfigured, Copilot will silently fail to generate inline suggestions due to an inability to establish a secure handshake. Our final flowchart illustrates the secure proxy authentication handshake. The IDE initiates an outbound connection, which is intercepted by the corporate proxy. The proxy challenges the connection for Kerberos authentication. By passing the configured service principal name and validating the custom SSL certificate, Copilot successfully authenticates, securely reaching the AI models to retrieve your code completions for quicktechie.com.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by Quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.